Okay, so here we are with Unit 7, lesson number 1, and right now we're going to look at just an introduction to solutions, and we've actually seen this already when we looked at the beginning of the course where we talked about matter and how matter can be broken down into subcategories, etc. So basically, the first couple of slides in this lesson number 1 is a review in a way. So we said that basically matter can be broken down into two subcategories. One would be substances, and substances are composed of both elements and compounds. The other category that it can be broken down into would be mixtures. And then mixtures, as you can see from this diagram here, mixtures can also be broken down further into two more categories or subcategories: heterogeneous mixtures, which we really don't talk about a lot, and homogeneous mixtures. And just a quick thing about these two diagrams. Notice the difference. The colors are the same. You have purple circles and green ones. But you notice a couple of things about them. First of all, you notice in the one on the left, under the heterogeneous mixture, and we would call these the components of the mixtures or the parts of the mixture, these different circles. Notice that the purple ones and the green ones are not necessarily evenly distributed. Notice that most of the purple ones are towards the top and the green ones are at the bottom. That's why this would be called a heterogeneous mixture, because the purple and the green ones are not evenly distributed. If you look at the one on the right, you notice how they are. Of course, it's exaggerated, but notice how the purple and green ones are evenly distributed throughout the sample. That's what makes this a homogeneous mixture. So as again, you can see in the example at the top, heterogeneous mixtures, the particles are not uniform, the components are not uniform. Soil or dirt, in other words, would be an example. Homogeneous mixtures, the particles or the substances that make up the mixture are uniform. In other words, they are evenly distributed. And another word for homogeneous mixtures would be solutions. So what exactly is a solution? And I think at the bottom, it gives you a good little diagram of what a solution is. So again, a solution is a homogeneous mixture of substances. If you look at the two terms underneath that, the solute and the solvent are the parts of every solution. However, that doesn't mean that there's always one solvent and one solute. Most solutions have one solvent and one solute, but they can't have more than one solute. And if you take a look at the bottom, here's two examples of solutions. And you notice in both cases the water is the solvent. And that's common because it's called the universal solvent, because water dissolves a lot of things, and we'll get into later on why that is. But in this particular case, we're going to dissolve sugar in it, sucrose, which is sugar that you would put in your coffee. It's commonly called table sugar. That would be the solute, and we drop that in the water, and that now becomes a solution. The sugar is the solute, the water is the solvent. And the same thing on this side. I'm not really sure why. One is more concentrated than the other. Solute and solvent is not really two definitions that you need to know, but you should be able to identify in a solution what the solute and the solvent is. There can be more than one solute. For example, in a can of Coca-Cola, water is of course the solvent, but there are a lot of solutes dissolved in that water. The most common one, or the one that's in the greatest amount, would be probably sugar. You'd be surprised at the amount of sugar in one can of soda. But there are also a bunch of other solutes, the coloring, like the caramel coloring, the caffeine. Those would all be considered solutes. So most solutions have one solvent, it's usually water, and it's a liquid, and have one solute, which is usually a solid, but it doesn't have to be just one solute. Now, what actually is the process of making a solution, or dissolving? It's sometimes called dissociation. The best example of that is when you place salt in water. That makes an aqueous solution. Let's just quickly run through this. Notice that the S means you're taking solid salt, sodium chloride, and you're mixing it with water. AQ means that this is dissolved in water. Notice what happens to the salt particles. They don't stay intact. They break apart. And they break apart into their ions. They break apart into an Na plus ion and a Cl minus ion. That's known as dissociation. That's basically what happens when a salt dissolves. So when you take a grain of salt, just one grain of salt, and put it in water, that's not one single Na and one single Cl. That's actually millions of NaCls. Keeping in mind, of course, how small they are. So now, what makes the salt dissolve in the water? Well, that's because the solvent is polar. In this case, water is polar. And if you remember, and let me draw this here, just to keep in mind, and this is an important thing here that you should remember. If I can get this down here, let me do blue. Okay, if you remember, when we did the water molecules, remember that water is what we call a bent shaped molecule, and that's what it looks like. The H's are not directly across from each other. And if you remember how to determine if a molecule is symmetrical, polar or nonpolar, is the lines of symmetry. So the only way that we can split this in half is this one way right down the middle. And because it has one line of symmetry, it's a polar molecule. Oxygen has a higher electronegativity, so this end will have a slight negative charge, and this end will have a slight positive charge. So this is a dipole or a polar molecule. That's extremely important, that water is a polar molecule. And that's because water is polar, it will dissolve solutes that are similar to itself. In other words, water being polar will dissolve any solute that is either polar or ionic. Water will not dissolve solutes that are nonpolar. And that's the phrase that you'll see later. It's called like dissolves like. You should write that on the side. Like dissolves like. That's a really important phrase. I'll write it here for you if I can get this thing to work again. And I'm sure we're going to run across it again. And this phrase is really important. Like, and we've seen this before. What like dissolves like. And that's a very important phrase, and that basically is saying that polar solvents dissolve polar or ionic solutes. That is one of the most important concepts in this course, because they will ask you, for example, why does one thing dissolve in water and not another? Well, obviously because whatever dissolves in water must be either polar or ionic. Let's finish this up. So dissociation occurs when ionic compounds, the ions that make up those ionic compounds, are pulled apart by the positive and negative end of the polar solvent. And you can see this diagram on the left hand side here, and I think there's a little bit of an animation which I think is a good explanation. So let's take a look at that. There is no sound, so again, you'll have to listen to me. So we're going to take some sodium chloride and add it to water. Water is acting as the solvent. And again, we know this is going to dissolve because water is polar. So here's what happens, and I can't pause it, but notice the water molecules. The oxygens are attracted to the Na plus ion because they're oppositely charged. And the H ends of the molecules of the water are positively charged. They're attracted to the Cl. So the water molecules literally pick apart the NaCl crystals until all of the Na and pluses are separated from each other. That is the basis of dissolving or dissociation. What keeps them from rejoining is because there's a shell of water molecules around each of those ions. So they're like bumper cars. They bounce into each other, and because the Na and Cl's are separated by those water molecules here, they can never rejoin again. And that's the process of dissociation. So let's go back to the notes. Alright, so again, what are the different types of solutions? Well, not every solution is a solid and a liquid. You can have solutions that can have just about any combination of phases of matter. You can have a solution that's made up of a gas with another gas. For example, the air is considered, in some cases, the atmospheric air is considered to be a solution that has a gas mixed in with another gas. You have oxygen, nitrogen, etc. Antifreeze is an excellent example of a solution that contains two liquids. Antifreeze is a mixture of alcohol and water, both liquids. A gas with a liquid, soda would be. The bubbles in soda would be carbon dioxide, and they're dissolved in water. Salt water would be a good example of a solid with a liquid. And you can actually have two solids that are a solution. I know it's hard to figure that out, but alloys are basically mixtures of two metals. For example, brass is a solution, a mixture of both copper and zinc. It is called brass. And that is the end of lesson number 1.